Good evening all. Today I'm going to work out exercise 1.1. First question is express each number as a product of its prime factors. First part is 140. So I'm working on my whiteboard. So 140, we know that 140 if we prime factorize 2 times 70, again 2 times it is 35, and we know 5 sevens are 35 and 7 into 1 7. So 140 can be written as 2 square into 5 power 1 into 7 power 1. Moving on to the next part. The next part is 156. So 156 can be written as 156 when divided by 2, we get 2 sevens are 14, so 78. So again by 2, 39, again by 3, and 13 is prime number, so we get 156 equal to 2 square into 3 power 1 into 13 power 1. Hence, this is the solution for this part. The next question is 3825. We know that a number ending with 5 is definitely divisible by 5, and 5 is a prime factor, so prime number, so we can definitely divide it by 5. So 5 times 7 is 35, so 3, so 5, so 765. Again when we divide this number 760 by 5, we get 153. Again when we divide it by 3, we get 51, and we know that 3 times 17 is 51, so 17 into 1 is 17. So this number is equal to 5 square into 3 square into 17 power 1. Moving on to the next question. The next question is 5005. So fourth part is 5005. We can write 5005 when divided by 5, we get 1001, and 1001 is divided by 3, we get it is not divisible by 3, so hence we can take it as when divisible by 11, it is divisible by 11, we get 91, and we know that 13 sevens are 91, so here it is the answer. So this 5005 can be expressed as 5 power 1 into 11 power 1 into 13 power 1 into 7 power 1. Moving on to the next question, next part of this question. The next part of this question is 7429. 7429, so that is 7429 is divisible by 17, we get 437. 437 when divided by 19, we get 23. We know that 23 is a prime number, so 23 into 1 is 23, so we can write 7429 as 17 to the power 1 into 19 to the power 1 into 23 to the power 1. Hence the answer. Now moving on, over here the second question is, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. So first is 26 and 91. So again, using the prime factorization technique, we are going to find the second question, first part, 26 and 91. So 26, we can simplify it by 2 table. 2 13s are 26 and 13 into 1 is 13. Similarly for 91, we know that 7 times 13 is 91. So 13 into 1 is 13. So 26 can be written as 2 into 13 and 91 can be written as 7 into 13. Now the actual question is, we have to find the LCM and HCF. Here we can see very well that LCM is HCF is 13 and LCM would be 2 into 7 into 13, and we know that 2 7s are 14. 14 into 13 we get it as 182. Moving on to the next part of this question. In the next, they have given us to find the HCF and LCM of 510 and 92. So in case of 510, 2 into 2 we get 4, so 1 carry, so we get 255 when we divide 510 by 2. So again, when we take 5 5s are 25 and 5 1s are 5, and we know that 3 times 17 is 51 and 17 itself is a prime number, so 17 by 17 we get 1. So this is for working for 510. For 92, 2 4s are 8 and here 1 carry, so 2 6 are 12. 2 into 23 is 46, so 23 when divided by 23 it is 1. So from here we can say that highest common factor is 2. LCM is equal to 5 2s are, so 1 2 is common, so we can take 1 2. So again one more 2 is there, into 5 into 3 into 23 into 17. So when you guys evaluate, you would be getting LCM. I am leaving to you guys to calculate the LCM value. The third part is 336 and 54. So 336 and 54, third part. So 336, when we divide it by 2, we get it as 168. Again when we divide it by 2, 2 8s are 16 and 2 4s are 8, 4. And again when we divide it, we get 2 4s are 2 2s are. Again when we divide, we get 2 2s are and 2 1s are. and then 3 we get 7 and 1. Next it is 54. 2 into 27 is 54. 3 into 9 it is 27. 3 again we get 3 and 3 1. So from this we can say that 336 is equal to 2 power 4 into 3 power 1 into 7 power 1. Similarly, 54 is equal to 2 power 1 into 3 power 4. So from this what uh, we can say that 54 in 54 it is 2 power 1 into 3 cube, and 336 it is equal to 2 power 4 into 3 power 1 into 7 power 1. Common thing in both of these is 2 power 1 into 3 power 1. So 6 is the common factor, so it is the HCF. Similarly, if we calculate for LCM, we can take it as 2 is one time common and 3 is one time common. So writing it one time. Other than that, there are 2 threes in for 54 and 2 and 3 twos in case of 336 into 7. If we multiply all these numbers, 2 threes are 6, 6 threes are 18, 18 threes are so after simplifying all these numbers, when we multiply it, say 2 threes are 6, 6 threes are 18, 18 threes are 54, and 54 into 2 it is 108, and 108 into 2 it is 216, 216 into 2 it is 432, and 432 into 7 we get 3024. Please note the answer. This is the answer. Moving on to the next question. Next question. Before moving on to the next question, I would just tell you guys that I have not verified that LCM into HCF part. I leave it to you guys to solve. I would just explain you guys with the help of this example 3 over here. Right? Over here, there are two numbers given. One is 96 and example 3. Just see to that. So if you guys just see example 3 over here, Uh, Find the HCF of 96 and 44, 404, sorry, not 44, it is 404 by the prime factorization method, and hence find their LCM. So 96, when we write 2 4s are 8, and 1 carry 2, again 2 2 4, again 2 we get 12, again 2 we get 6, again we get 2 3, again we get 3 1. Here they have simplified and written as 2 power 5 into 3. And similarly, 404, 404, again by 2, 202, again 2, 101. 101 is a prime number, so again dividing by 101 itself, so we get 101. So we can write 404 as 2 power 2 square, 2 square into 101. So this is the answer simplified and given over here as 96 into 2 power 5. 96 is equal to 2 power 5 into 3, and 404 is nothing but 2 square into 101. From this we can say that 2 power 2, 2 power 2, that is 2 square is common, so 4 is the HCF of these two integers. So with this we can find that we know the concept that HCF of two numbers into LCM of two numbers is product of those two numbers. Let's say it is A and B. Over here the A and B are 96 into 404. So to find out the LCM, we know that HCF is 4. It will be in the denominator part, and we know the other two numbers given as 96 and 404. When we simplify this cancel 101, so 96 into 101, 96 0 0, again 96, so 9696. This is the simplified answer. So we are getting the same answer as given in the book. So similarly, I'm giving you guys a work to be done. I have found out the normal LCM and HCF of the second question part. Similarly, in case of third question, I am going to find out the LCM and HCF. But in case of question 2, you guys are going to verify whether LCM times HCF is coming out as product of two numbers, right? So now moving on to the third question. Third question is find the LCM and HCF of the following integers by applying the prime factorization method. First question is 12, 15 and 21. 12, 15, 21. So now let's start. We know that 12 is divisible by 2. 2 6 are 12. Again 2. 2 times 3 is 6. So 1. For 15 it is 3 5s are 15 and 5. And in case of 21 it is 3 times 7 and so 12 is equal to 2 square into 3 power 1. 15 is equal to 3 power 1 into 5 power 1. 21 is equal to 3 power 1 into 7 power 1. Right? So we have to find out the HCF and LCM of these three numbers. What are the numbers common in all the three? So if we see 3 power 1, over here also 3 power 1, and over here also 3 power 1 is common. Hence HCF is 3. 3 power 1 is nothing but 3. Similarly LCM, so all the 3 power 1 ones I am writing over here. 3 power 1 into I am writing LCM over here. So 3 power 1. So 3 into 2 square is 4. Into 5 into 7 into here it is 5. So 3 4s are 12, 12 5s are 60, 60 into 7 it is 6 7s are 3 4s are 12, 12 5s are 60, 6 7s are 42. Sorry. So it is 420. LCM is equal to 420. That's the answer. Moving on. The second part is 17, 23 and 29. So 17 is a prime number. We know very well. So 17 is, so I am directly writing. So 17, 23 and 29. 17 is equal to 1 into 17. Similarly 23 is equal to 1 into 23, and 29 also is a prime number, so it is 1 into 29. Hence the highest common factor is equal to 1 itself, because 1 is the only thing common in all these three cases or three numbers. So in case of LCM, it would be product of 17 into 23 into 29. Right? So when we multiply all these numbers, we get 11,339. This is the LCM. Moving on to the next question or the next part. The third part is 8, 9 and 25. We know that 8 is nothing but 2 times 2 times 2. 9 is equal to 3 times 3. And we know that 25 is equal to 5 times 5 times. So actually we know that 8 is nothing but 2 cube, right? 9 is nothing but 3 square, and 25 is nothing but 5 square. Oh, so if they don't have anything in common, whereas we can take 3 into 3 into 1 is also 9. So similarly 5 into 5 25 into 1 is also 25. So we can say that all these have HCF as 1. Okay. So in case of LCM, we have to multiply 8 into 9 into 25. 8 9s are 72. 72 into 25, we get 72 into 25, we get 2 5s are 10, 1 carry. 7 into 5. So when we solve, 2 5s are 10, 1 balance, 7 5s are 35. So 1 plus 1, 36. I'm leaving one space. 72 into 2 we have to calculate now. 4, 2 2s are 4, 7 2s are 14. So when we add these, we get 0, 6 plus 4, 10, 1 carry. 1 plus 3, 4, 4 plus 4, 8. So we get LCM as 1800. And thus third question is completed. Moving on, fourth question is, given that HCF of 306 and 657 is equal to 9. They have given two numbers and they have given the HCF it directly. We have to find the LCM of 306 and 657. And the two numbers are 306 and 657. We know the concept that HCF times LCM is product of two numbers. So we have to find out the LCM. So how can we find? We know that HCF into LCM is product of 306 into 657. So 9 into LCM is equal to 306 into 657. So to find out LCM, we can rewrite it as to find out LCM, we can rewrite this as 306 into 657 by 9. So when we cancel out 9 and 306, we get 34. So 34 into 657. If we compute, we will get the LCM. We get the answer as 22,338. This is the answer of LCM. Moving on to the next question. Check whether 6 power n can end with the digit 0 for any natural number n. So we have to check whether 6 power n can end with digit 0 for any natural number n. We know that natural numbers means we have to consider only from 1. So checking, we know that 6 power 1 is 6, 6 power 2 is 36, 6 power 3, 6 power 4. So 6 power 1 is 6, 6 power 2 is 36, 6 power 3 is 216, that's 216, 6 power 4 is 1296. So if we see the pattern, we can very well say, we know that 6 is multiple of 3. So the multiple or divisibility test, according to the divisibility test of 3, we can very well say that if any number is divisible by 3 and 2, it will be divisible by 6. But there is no digit which can end with 0, because a number, if it is divisible by 2, it can be ending with 0, but if it is divisible by 3, it is mostly not ending with 0, right? So it should be both divisible by 2 and as well as it should be divisible by 3. Hence 6 power n cannot end with the digit 0 for any natural number n. Next question is, explain whether or explain why 7 into 11 into 13 plus 13 and 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5 are composite numbers. We know that what are composite numbers. Composite numbers are those numbers which have factors other than 1 and the number themselves. For example, if we take 8, we have 2 and 4 other than 8 and 1. So 8 is a composite number. We have to explain that these two combination, that is 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So seeing with the first combination, 7 into 11 into 13 plus 13, here we have 13 in common, so taking 13 out, 13 into balance we are writing inside the brackets, 7 into 11 into 1 plus 1. So if we simplify, 13 into 7 into 11, it is 77 plus 1, which is equal to 13 into 78. So 13 times 78, we can write it as 13 into 78. If we prime factorize, we get as 3 into 2 into 13. Hence, it is a composite number. It is a composite number. We have proved the first part. The second part is, seven times 6 times 5 times 4 into 3 into 2 into 1 plus 5. So here 5 is occurring 2 times, so taking 5 as common, so 5 into is equal to 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 5 ones are 5, so I am writing 1 over here. So when we simplify, we get 5 into 1008 plus 1. So 5 into 1009. So when we multiply these two numbers, we are definitely going to get a composite number. Hence, this is also a composite number. Moving on to the next question. So we in sixth question we have proved that both the given combinations in the questions is a composite number. So moving on to the seventh question. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So There is a circular path. Let's say S for Sonia and R for Ravi. They both start at the same point. Let's say it is here. For Ravi, it takes 12 minutes. For Sonia, it takes 18 minutes. They move in the same direction. Let's say this is the direction. So, after how many minutes they will meet? This is the question asked. So, the given data is Sonia takes 18 minutes and Ravi takes 12 minutes to complete one drive, one round, right? So, simply, indirectly, they have asked the least common multiple, that is LCM, of both the minutes taken. So, let us find out the least common multiple. So, we are going to take LCM of 18 and 12. We know that 2 times 9 is 18 and 2 times 6 is 12. Again, 2 times 3 is 6 and 9, it is not divisible by 2. Now moving on to 3. 3 3s are 9 and 3 1s are 3. Again, when divisible by 3, when divided by 3, we get 1 1. So 2 into 2 into 3 into 3, that is 2 to are 4, 4 3s are 12, 12 3s are 36. So they will meet again after 36 minutes. This is the answer for this question. Moving on. So that was the exercise 1.1 answers. So next exercise is exercise 1.2. It is given here. The first question is prove that root 5 is irrational. I am just going to explain how to prove that root 5 is irrational with the example of example 5. Here we have to just exchange the numbers, that's it. So over here it is given as root 3 is irrational. So first step is we have to assume that root 5 is rational. We have to assume. So here instead of root 3 we have to write as root 5. That is, we can find integers a and b where b is not equal to 0 such that root 3 is equal to a by b. So we have to write root 5 is, since it is a rational number, it can be written as in the form of a by b where b is not equal to 0. Right? Suppose a and b have a common factor other than 1, then we can divide by the common factor and assume that a and b are co-prime. So b root 5 is equal to a. Now squaring on both the sides, we get 5b square equal to a square. Therefore, a is divisible by 5. If a is divisible by 5, then a is also, if a square is divisible by 5, then a also is divisible by 5. Please follow me over here. With this I said a square is divisible by 5, then it follows that a is also divisible by 5. Then we can write a as 5c for some c. Then when we substitute for a, we get 5b square equals, so actually we are squaring on both sides, so at that time we get, here to remove the root we are going to square, so here we get 5b square equals a square. So if we are taking for some a is equal to 5c, we get b root 5 is equal to 5c, right? Now again we have to, I'm just substituting over here this value over here. Here we have taken a equal to 5c. So b root 5 the whole square, again taking out the square root, which is equal to 5c the whole square. Hence we can say that 5b square is equal to 25c square, right? So 5b square is equal to 25c square. Here we have to write the same statement. Therefore a and b have at least 5 as a common factor. But this contradicts the fact that a and b are coprimes. So this contradiction has arisen because of our incorrect assumption that root 5 is rational. So we conclude that root 5 is irrational. Thus, this is the proof of how to prove root 5 is irrational. Similarly, for the question 2, prove that 3 plus 2 root 5 is irrational. So we can write with the help of this sixth example, I'm going to tell you guys how to write 3 plus 2 root 5 is irrational. So let us assume to the contrary that 3 plus 2 root 5 is rational. So hence if they are rational, we can write, so we can write as 3 plus 2 root 5 is equal to a by b. So we can rewrite this as, so 3 plus 2 root 5 is equal to a by b. So we can rewrite this as 3 minus a by b is equal to 2 root 5. So when we simplify them by cross multiplying, 3b minus a by b is equal to, sorry it is root 5 over here, is equal to 2 root 5. When we take this 2 over here, we get as 5. We know that root 5 is irrational, so we can conclude that 3 plus 2 root 5 is irrational. Similarly, we can also prove for the third part, that is 1 by root 2 and 7 root 5 and 6 plus root 2.